In this video, we will answer some sample problems that often comes up in an exam, especially in analytical chemistry, particularly finding the mass of an element from a given mass of a compound. For instance, you see here in number one, this is from a book example from school. It's actually a good book for learning analytical chemistry, and I use some of its question as a reference because it is often used by teachers as well as reference. So by practicing it, we may be well prepared for some chemistry problems they may make. Okay, so for number one, we have here, what is the mass in grams of sodium ion, which has a molar mass of 22.99, in 25 grams of sodium sulfate, or Na2SO4, with a molar mass of 142 grams per mole. Okay, so in answering this type of questions, let's focus on the given mass. So here we have 25 grams, right? So since we are starting with a sodium sulfate here, let's use the molar mass of sodium sulfate, okay? So 25 grams of sodium sulfate. Then let's use the molar mass. So 1 mole of sodium sulfate weighs 142 grams. Okay, now we can cancel grams, and now we have the mole of sodium sulfate. Okay, this one we need to see how many sodium in sodium sulfate. Okay, 1 mole. Okay, we have 1 mole of sodium sulfate. How many sodium ions are there, or sodium in sodium sulfate? So we have 2 Na, right? Na is sodium. So we have 2 Na. So 1 mole of sodium sulfate means there are 2 mole of sodium ion. Okay? There are 2 sodium in 1 sodium sulfate. And now we know that the molar mass of sodium here is given. So if this is not given, you may be using periodic table. So this can be found in your periodic table, the molar mass of sodium. Okay. So 1 mole of sodium, or sodium ion, is 22.99 grams. Okay. Now we can calculate 1 mole of sodium sulfate, mole of sodium. Now we're left grams of sodium. So we were asked to find the mass in grams, right? So simply by inputting this in your calculator, you will get 8.095, or 8.10 grams. Okay, so this is the mass of sodium. Sorry, sodium ion. So there are 8.10 grams sodium ion in a 25 grams sodium sulfate. Okay, 8.10 grams sodium ion in 25 gram sodium sulfate. Okay, so that's easy, right? So let's answer the next question. So quite similar to number one, but with different given chemical. What is the mass in grams of calcium ions with a molar mass of 40.08 grams per mole, present in 18 grams of calcium nitrate, or CaNO3 2, with a molar mass of 164.09 grams per mole? Okay, so this is the same thing with number one. So let's start with the given grams. So the given grams is from calcium nitrate, or calcium CaNO3 2. So When this molar mass is not given again, you can use your periodic table. 18 grams of calcium nitrate. So 1 mole of calcium nitrate is 164.09 grams. Okay. Now we want to know or to see how much calcium are there in calcium, 1 mole of calcium nitrate. So 1 mole of calcium nitrate, okay, you can actually see it in its chemical formula, right? So there is only one calcium as well. So one calcium ion is actually in one calcium nitrate. So 1 mole of calcium ion. See, there's only one calcium here. So 1 mole of calcium ion weighs 40.08. So again, this can be found in your periodic table. 40.08 grams calcium ion. Okay. So using calculator, let's see. So let's cancel the unit first. And then we are left with grams of calcium ion. Okay. So by using your calculator, the amount of calcium ion in the calcium nitrate is 4.397, or just 4.40 grams calcium ion. Okay, so there are 4.40 grams calcium ion in calcium in a 18-gram calcium nitrate. Next, calculate the mass percent of potassium. So we're asked with mass percent this time. Mass percent. So the unit would be in percent of potassium, which has a molar mass of 39.10 grams per mole. So this is the K in periodic table. And we want to calculate the mass percent of potassium in potassium dichromate, or A2Cr2O7, with a molar mass of 294.18. So in order for us to find the percent, okay, to get the percent, you actually have this. I this above would be the mass in question, base mass. Basically times 100. Okay. So basically, mass in question would be the molecule or the analyte, for instance, that we want to find. So in this case, we want to find the mass percent of potassium. So mass in question would be the potassium. Okay. Now base mass would be the mass that we want to base on. Okay. So it's basically in this case, we want to know the mass percent of potassium in potassium dichromate. So this would be the K2Cr2O7. So this is basically what I remember or what I picture when I'm calculating percent or mass percent of a compound or a molecule. Okay. So to answer this question, let's assume, okay, assume you have 1 gram of the base mass. So let's assume that we have 1 gram of K2Cr2O7. Okay, this is our assumption. This is 1 gram. Okay, let's say we have 1 gram of K2Cr2O7. So for this, we can use the molar mass to get the mole, right? So 1 mole of K2Cr2O7 weighs 294.18 grams. And just like the previous question, 1 mole K2Cr2O7. And how many potassium, since we are dealing with potassium, which is our mass in question, how many potassium are there in potassium dichromate? There are two, right? So there are 2 mole of potassium. Okay. And then we can use this 1 mole of K using its molar mass. We know that it is 39.10 grams per mole. Now we have to multiply it by 100. Okay, since we were dealing with percent, so this be the last. So using or okay, this is be let's just put it 100%. Okay, we can cancel this, cancel, and we have 26.598% or just 26.60%. Okay, so 26.60% potassium, okay, in K2Cr2O7. So this is the mass percent of potassium. As you can see from this problem, we are using the same approach, but with some difference here. So we use 100% and we assume some things. In this case, we assumed 1 gram of the base mass, which is our K2Cr2O7. And this is practically easy, right? Just by using dimensional analysis that we want to get percent here in the last part. So we got 26.60%. So we have okay, a tricky question here. So number 4. A fertilizer sample contains 46 grams of urea, which is CO and H22 with a molar mass of 60.06 grams per mole. Calculate the mass percent of nitrogen in the fertilizer sample. So this is the same thing. We are dealing with mass percent, or we are asked to find the mass percent. But the difference is we're given a mass here of our base mass, right? Remember our formula, right? So it is mass in question over base mass times 100. And in and this time our mass in question would be nitrogen, right? Calculate the mass percent of nitrogen. So this is N. And our base mass would be urea or CONH22. But this time we are given with a mass or the mass of the sample. So this given mass here is basically not relevant in this type of question since, okay, note here, note percent by mass depends only in the given chemical formula. Okay, so what does that mean? This mean that this is um basically just the same thing with the in the previous question, which is number 3. We don't need to use this one. Okay, so this is just for confusion. So basically, what did we do in the previous question, right? So we just first we assumed 1 gram of the base mass, right? So 1 gram of our base mass or or base mass in this case is CONH2, which is urea. And using the molar mass given, 1 mole of CONH22 is 60.06 grams. And 1 mole of urea or CONH2, how many nitrogen, since we're mass in question would be the nitrogen. So there are two nitrogen actually, right? So here NH22, right? So basically that's like 2N and 2H2. So basically 4H. But we were dealing with nitrogen here. So we have two nitrogen. So there are 2 mole of nitrogen. Okay. So if you look at the periodic table, 1 mole of nitrogen is actually around 14.01 grams nitrogen. And multiply it by 100. Then using your calculator, and that would be 46.65%. So there are 46.65% nitrogen in your urea or your fertilizer sample. Okay, so you don't need to use the given mass. So in this case, it's probably the same thing, right? 46 grams of urea and 46.65%. But just remember, that percent by mass depends only in the given chemical formula. And this actually is like a real life uh, value for fertilizer. So this is a common label in fertilizer that we can see. It's 4600 fertilizer. So basically mean that 46% nitrogen by mass of urea. So it's a common label in fertilizer products. So yeah, so this is like a real life example. So yeah, that's it. It's easy, right? So I hope you learn a lot from this video, and if there are questions you want me to answer, feel free to comment down below. And don't forget to like and subscribe to support the channel. Thank you.